Hello guys, welcome to this new video. This is our fifth question on LeetCode, and we are at this problem called longest palindromic substring. Okay, till now we have solved four problems, out of which some of them we had a better understanding. We did it with a brute force method. I mean, all of them we tried to do with brute force method and a new approach. Okay, in this question, we find that we have to um, find a palindromic substring. Okay, a substring which is palindrome, considering this ABA is a palindrome. As one who does know what is a palindrome, palindrome is a string which reads the same forward and backward. Okay, and what is a substring? As we know, is a contiguous non-empty sequence of characters within a string. Okay, if you ignore the non-empty sequence of characters, you just remember that substring is a sequence of characters in a string. Okay, which can be a part of a string. Can be BA, can be AB, ABA, ABD, BD, BAB, anything, any part. It can be the whole string also. Okay, so we have to find this longest palindromic substring. So if we try to imagine how we are going to solve this problem, one may think that we will write a separate function for writing the palindrome of a string. Then we will run two for loops in which we will start from this BA, then BAB, then BABA, then this whole string. Then we will see start from here AB, ABA, ABAD. Like this we will run two for loops and check which is the longest one. Okay, until now, and we will return that string. Okay, so that is a very new approach, and it is over fan square. Definitely we can solve the problem like that, but we have solved the four problems till now with a new approach, and definitely in this problem we'll try to learn something new, a new algorithm, a new method of solving a substring problem, a subarray problem, and this will also help us in the future while we are solving problems related to strings and arrays, when we need to do any operation on this substring or a subarray. Okay, a part of array or a part of string, and we have to uh, calculate something like consider we have to calculate the sum of a array, a subarray. Okay, where we have 1 2 3 4 5, and we have to find two numbers which calculate to 5. Okay, two numbers which calculate to 5. So this 2 and 3 will be the answer, but for writing a code for this, you see, we have to go through all this and search for two numbers which add up to 5. Okay, so the target is 5. The number maximum numbers we can choose is 2. So this problem and all other problems related to the subarray and substring we can solve using a window sliding technique. Okay, or sliding window technique, where you have to choose the window, and we'll start from this array itself, I mean the first index, and we will check if it it adds up to the target to 5. Otherwise we will increment the right pointer and also the left pointer, and we'll move forward. If this matches, if it's true, we will save it as the two numbers which are adding as a target 5. Okay, then we go here, then we go here. So this window which moves from left to right, right to left, from center to, and it can also expand like from center like this and like this. Okay, and from it can go from left to right, right to left, and from center to the very left and right of an array of substring. Okay, so there are three methods where we can move the window. One is from left to right, one is from right to left, and one is from center to the end of the window. Okay, yeah. So the algorithm which we can come up with, okay, for this problem statement is we have to run this. Okay, we have to just first imagine how we are going to first we have to look at this, how we are going to solve this problem. Okay, how we are going to solve this palindromic problem using sliding window technique first of all, and how we are going to find the maximum sum. Okay, and then how we are going to return the string, okay, which is the maximum one. So in this session we'll definitely learn a sliding window problem, sliding window technique. Okay, let's leave what is sliding window technique. Okay, so best example is Geeks for Geeks. This I see there is a lot of things to read, but I will explain to you in very small and fast, quick video, and go through all the important points. Okay, so just take a look at here. So instead of a brute force approach where we have of n square time complexity, we can optimize uh, finding a key size subarray. Okay, by using this sliding window technique, as they say. So left pointer is at 0, right pointer is at 1 0 1 2. Okay, and the window size is 3. So window size will be given or may not be given. It depends upon what our problem statement is. And window size can increase, window size can decrease. Okay, depending upon the condition satisfies or not. So our current sum is 9. 6 plus 2 plus 1 is 9, and the maximum sum is 9. We have to find a sub array which has a maximum sum. Okay, so it goes on moving to the right. If a, here our condition doesn't satisfy, does I mean the condition, there is not a condition to be satisfied. We have to just find the maximum sum. So we'll move our window from left to right. Okay, and as you can see here, we started from left here and right pointer here. We kept on incrementing it, the both pointers, and we went till the end of the array. Okay, it's very easy to write this problem. Okay, uh, if you want, let's try troll this first and we'll get an idea what we are trying to do here. Okay, let's write a question here. Okay, let's write a function here. First function, we are going to write the maximum sum in a subarray. This will also let us understand how we are using sliding window technique by just looking at this image, and the question. Okay, so the question here is, let's say we have an array of size n. In this case it is 1 2 3 4 5 6, and now also an integer known as k. So in our case it is 3. K is 3. Now we have to calculate the maximum sum of the subarray having size exactly k. The window size must be k. And how should we approach this problem is one way by taking each subarray of size k from the array and find out the maximum sum of these subarrays. This can be done using nested loops, which will result in O of n square time complexity. Okay, the one way to doing is subarray, taking each subarray of size k from the array and find out the maximum sum of these subarrays. Take a for loop. Okay, 1 2 6 2 6 2 6 2 4 2 4 1. Okay, like this, using a for loop, but it will take 2 for loops. Okay, to find each of this answer. Okay, and we can optimize that using sliding window, and we are going to see how. Okay, so we the question is, we have n and we have k. Okay, so let's say we have array of size whatever we can pass from there, and then we have k. Okay, so we got size n is equal to array dot length. Okay, We are going to call this maximum sub in array by passing an array and size of 3. Here, let's take this same example 126241, and we have 126241. Okay, the sizes of the window is 3. Okay, we will run a loop until the size of the until let's say we have I, that I is equal to 0 and I is less than array dot length, that means n. Okay, and we will increment I, but before that let's take, so we will have right pointer and left pointer, and we are going to shift our range. We are going to calculate the sum till 0 to k minus 1. Okay, let's not make it generic for just 3. We'll write it for all. Okay, for k minus 1 up to k minus 1. Okay, and we have to just calculate the sum for 0 to k minus 1. Okay, now this k can k will be incrementing all the time. It will be only 3, definitely window size is 3, but we have, as we have to move this k, okay, but the size will be 3, and now we have to calculate its sum and shift our range one by one along with the iterations and update the result. Okay, so if you see, there are two types of sliding window techniques. The one is fixed size sliding window technique, which we are solving right now here. Okay, another one is variable size sliding window technique, which we will be needing in our palindrome problem. Okay, so if you take a look here, the general steps to solve these questions are: find the size of the window required, say k, compute the result for first window that includes the first k elements of the data structure. Okay, we have to think, because k is dynamic, we have to think for a while how we are going to move through k and calculate the sum here. Okay, for that we can run one for loop which runs from 0 to k minus 1, and once it calculates that, we can also edit k. We increase the pointer of k and k from 0 to 1 and k minus 1. Okay, let's see how. Let's just understand this first. Compute the result for first window, that is include the first k elements of the data structure. Then use the loop to slide the window by 1 and keep comparing the result window by window. Okay, this is what we are going to do right now. Okay, then this variable size sliding window, I will come to this later. Okay, when we understand first the fixed size sliding window. Okay, now this is our input array. Consider and k is equal to, so we have to find the maximum slide window sum. Okay, so there are some examples given in C, C Sharp, Java, C Sharp and JavaScript. Okay, we'll take a look at how our JavaScript code works. Okay, and I will make you understand it in a very easy way. Okay, so we are finding maximum of a subarray of size k, initializing the maximum variable to 0, run a loop from I to k. Okay, what is I? I is 0 up to k. So k is 3 consider. Okay, we are going to run our I to 3 number. So this is a 3 size of window. So we are going to run from 0, 1 or 3. So k, because k is 3. And then we are going to calculate the sum of this 1, 4, 2, which is 7. Now what we do is we initialize a new window sum and assign that maximum for the window sum. And we start a new for loop in which we initialize I as k. Okay, I is equal to 3, 0, 1, 2, 3 means from here, and we go till the last of the array. So what they're doing here is window sum is equal to window sum, that is the max sum, means this sum minus array of I minus k. So what they're doing is they're taking the max sum, which is nothing but the sum they calculated for the first window. Okay, 1, 4, 2, that is 7. Now what they're doing is they're taking the 7 here and subtracting array of I minus k. That is, consider I is 2, the 3. Okay, so we start from 3, 3 minus 3 is 0. Okay, and plus area of I, which is nothing but 3, which is nothing but 10. Okay, so what you're doing is area of I minus k is nothing but 0, and this is 10. So they are subtracting 7 minus area of I minus k, which is 0, and area of I, which is the current number, 10. Are you getting it? What is happening here is we are moving the slider in such a way that we are subtracting the number from this window, the new window which we are creating, which is 4 to 10. They're subtracting this number and adding this number. So now this is our new window, 4 to 10, and we are saving the maximum number. If window sum is maximum, we save that here, and once this for loop finishes, we are return that maximum sum. See, we are only going to move this window once through the whole iteration. That's why first we calculate this window. Now when we want to add this number to this, we add it, but when we remove the last number. And how do we remove it every time? How do we remove the last number every time? Because we know the size of our window, which is nothing but k. Okay, so we subtract 3 numbers, 3 indexes behind. Okay, so we start from k and we subtract from k. That means if we are at 2, so what will be k? So 2 minus 3 will be, so consider a second case where we are done with this 4 to 10, and we got the maximum number here. Okay, the max sum. Now we increment I, and our I is this 2. Okay, and in that case window sum is still, window sum is no, sorry, the window sum is new sum, which is 4 to 10, that is 16, and 16 minus, what we do is we increment we remove this I, k minus 1, which is nothing but I is here, the 1, 2, 3, 4, 5. So 5 minus 3 is 2. So we are at a very great number. See, the thing is I keeps on incrementing, and that's why, and k is constant. So as soon as wherever we are at I and we remove 3 from it, we are here at 2. If our I is here, we remove 3. If we make a window which is 3 numbers behind of I, which is 3. If we make a window here, we'll definitely remove 2 from that sum. Okay, I'll show you how in our problem statement. Okay, so my assumption here was I will start by running a loop where I will definitely increment this, but I was confused how to make a window here, because I was thinking I will calculate every time, I will calculate using a for loop for this length, for k is whatever k is equal to, consider this 3. I will I will return the index of the starting element, which is 1. Then I will return 2. Then I will return 6. Then I will return 2. Okay, until our k minus 1. Okay, if until this last index is not, until the last index is less than the length of the array. Okay, I was going to do like that. We can also do like that, but this is a method that they are using here. They must have explained what they are doing. So let's analyze the problem with brute force method. We start with the first index and sum till the kth index element. Okay, we do all for possible consecutive blocks or group of k elements. This method requires a nested for loop. The outer for loop starts with starting element of the block of k elements, and the inner for the nested loop will add up till the kth element. Okay, that's not we are not getting it what we are trying to say, or maybe you're not understanding it. The method I was going to try, let's try that. If we fail in that method, we will try the method which they have listed there, and I think that is also easier one. That is an easier one. The one which we are trying right now, which is my method, which I think unless I won't try, I won't understand what uh, unless I won't try, I won't understand. So let's try that. See, what I'm doing is I am going till I less than n. Okay, which is the length of the array. uh, According to me, we need k which can be 3. Consider k is equal to 3. Now length of the array is equal to 6. I is equal to 0, and we start by saying we start by taking a window, okay, till k. Okay, and then we can increment that k, and then we have to stop where I is equal to, so we need to put a break condition. If I is equal to the length of array minus k. Okay, that means 6 minus 3, which is 0, 1, 2, 3. Definitely we have to stop here, because then the window will be this and we can't go further, and we have to break our for loop. Okay, that is the condition to break our for loop. So I think instead of putting it here, we can put that here also. I is less than equal to, we can say, n minus k. Is it? Okay. 0, 1, 2, 3. Yeah. So including that index and 3 other 2 indexes, including this index and other 2 indexes, let's calculate the sum. Okay, where we will say we run a for loop for until the k elements. Okay, and we'll calculate the sum. I think we are getting a for loop. Yeah, g, I'll take g, and we'll go till k 0 1 2. Okay, now we'll run a sum. Let's call it as let max sum is equal to 0, and then we will add maximum plus is equal to array of j. This will calculate I 1 2 3. Okay, now after this we'll increment our I. Now our I is at 1. So I think we should start j from I, because it will always start from 0, but if we are incrementing I, we should start from now 2 to 6. After increment I, we start from 6 to 4. Increment I, we start from 2 to 4, and we have to stop it there itself. While I is less than equal to n minus 1, n minus k, yeah. So I think we should break it. We should keep it running while I is less than equal to n minus 1. Once it is not less than equal to n minus 1, it breaks, right? So when we increment I to this 1 0 1 2 3 4, so when it becomes 4, at that time we break the loop. Okay, and we don't want the maximum there. So before I go to any conclusion, let me handle this by, I think let's keep let local max is equal to 0, local max, and we'll update maxsum as math.max of the local max and the maximum. So we get the maximum number, and then we come out of the loop, and then we can return the maximum. Okay, let's console log whatever we are trying to return. So there is an error here, k is not defined. Okay, my bad, I should define it as k here. Anything else? Okay, what is the issue here? K is not defined. Yeah, that will work now. The answer is 9. Okay, so let's see what our answer can be. If our window is 3, 1 2 6 gives 6 7 8 9, correct? 6 2 2 gives 10, that is then this is wrong. 6 2 4 gives 12, and then this will give definitely less. So we start from I and go till acha. Okay, so we're not incrementing k. See, k is always 3. We have to keep it definitely 3. So we should keep it k plus I, and that will help, I guess. And then answer is 12. See, why we did k plus I is, if we are starting from I, we should go 3 elements ahead of I. Okay, and we should stop there. Consider we are at 2, we should stop at 3 elements ahead of I. How many elements? 3. So whatever k is, we should stop at there. Okay, this is how our maximum subarray problem looks like. We are definitely using one for loop here, as one for loop is for constant time of k, it will run for k constant, k is a constant, so this doesn't run from the length of the array. Okay, and this is only one for loop. This runs for constant space k, and this runs for up to n minus k. So this is solved now, and now we understood what is fixed sliding window technique. Okay, so you have got an idea about what we are trying to do here. Is see, anyone with a basic understanding of this algorithm can solve this problem, as we are just taking a window and moving this window till here to here, here to here, here to here, here to here, and we are stopping. Basic understanding of for loops and while loop you will be able to solve this problem. You just need to understand the algorithm here. Okay, and now let's move to our variable size sliding window. Okay, the general steps to solve these questions is given below. So in this type of sliding window problem, we increase our right pointer one by one till our condition is true. Okay, so what happens here is forget about this. Okay, and just let's take an example of an array where we have 1 2 3 4 5 6, and there is a problem statement given which says that we have to find a maximum sum which is 10. There is no window given. Okay, you won't be given a window every time you solve the problem. Like in our case, for this fixed size window problem, it was given the window must be key. I'm sorry, I had to drink some water. Just give me a second. Yes, so yeah, in this variable sliding window problem, we won't be given the k, and we have to find we have to find the maximum number or the minimum number, and we don't know when the condition satisfies, so we need to keep on incrementing the right pointer. It can be 1 4, first we'll check for 1 4, then 1 4 2, then 1 4 2 10 23, unless the condition is satisfied. Okay, if the condition is satisfied, we'll stop there, and then we'll increment, and then what is the return? We increase our right pointer one by one till the condition is true. At any step, if a condition does not match, we're showing the size of our window by increasing left pointer. Okay, again, when our condition satisfies, we start increasing the right pointer and follow step 1, and keep moving the right pointer until our condition is true. Again, when our condition satisfies, we start increasing the right pointer and follow step 1, and we follow the steps until we reach the end of the array. Okay, so what happens in our longest palindrome problem is I think it is going to take 2 parts of this video because it will be a longer explanation. But if you once understand how we are going to move this window in our palindrome problem, it will be very easy. Okay, okay, yeah. So see here, what we are trying to do is, our question says return the longest palindrome in S, and this is a string. Consider this is like an array, and we also access the members of the string like an array. So B A B A D. Okay, so a string can be anything, can be empty string also. So let's add that check that if it's an empty string, we return empty string as a substring palindrome. Okay, next is we definitely need to run a for loop where I is equal to 0, I less than total length, I plus plus, Okay, so this we will definitely have only one for loop for iterating over this array or a string in a sliding window technique. And whatever you have to do, you make run another for loop, another while loop inside that, but we'll iterate only once through this. Okay, you can do multiple operations inside it. Okay, taking the index as the main pivot. Okay, you can move that pivot to left or right, right or left, and your left right pointers you can expand them, and you can move to left or right anyways what you want, but there will be only one for loop for iterating through the index of the string or the array. Now as we are going to move through this uh, string, we need to check here if a string is palindrome or not. A string is palindrome if it's a mirror from the center, right? So this, if we look from the center, A B A D, it's not a palindrome. What is a palindrome is A B A. This is a palindrome. Then A, sorry, B A. Yeah, this is a palindrome. So if you keep your point at the middle, if you see the left and right are equal, so that is a palindrome. So at any point in a string, it can be any big. We have to find if any part of the string that is a palindrome, which can be, which always starts from the middle, from the center. We on the method to check how a palindrome comes is you take the center and you check on left and right. A and A are equal, so this is a palindrome. Now expand this left and right pointers to left and right. So B and D are equal. No, they are not. So that's not a palindrome. We start from the index. We increment index from this to this, from 0 to the end of the array. And in between, we check. We will run a while loop. Okay, we will run a while loop and check if the left and right are equal. If the left and right are equal, we will increment our left and right pointers to right side. The right will go to right side and left will go to left side, and we'll check if uh, if they are equal or not. If they're equal, that means it is a palindrome. If they're not equal, that means they're not a palindrome, and then we can just return the current index. Okay, consider like we are at B, we found A and B as palindrome, ABA as palindrome because A and A are equal. So we increment our right pointer to D and increment our left pointer to B. So now this whole thing we are checking. No, we are just checking the left pointer and right pointer are equal or not. If they're equal, we will consider this as a whole palindrome. If they're not equal, we'll consider them as a, if they're not equal, we will consider them as not a palindrome, and whatever this we have till here, we'll return that. Okay, that's why we need to check, we need a function to check this thing, where we will increment our left and right palindromes, and we will we will increment our left and right pointers, and we'll check if they are the members of that pointers of that index are matching or not. I'll show you how we do that. Expand from center will be our name of the function. I've already seen these things, and that's why I'm able to explain you and also make myself a revision of this and solve this by myself so I can understand more better. You also go and solve this by yourself so that you can understand it better by yourselves, because looking at someone else's code and just trying to do the same thing they are doing won't make you a good developer at solving DSA problems or any problem statement in your career. You need to do it by yourself. Nowadays you have ChatGPT, you have so many AI tools available like Copilot and other things which help you solve the problems. But if you don't try to understand what ChatGPT and Copilot are doing, you won't be able to understand and fit in this current market of developers where the newcomers are just giving a statement, a prompt to ChatGPT. ChatGPTs are giving their answers, and ChatGPT is giving their answers, and the developer knows nothing. Let's not just make that happen and try to be smarter than ChatGPT. Try to understand and learn from ChatGPT. Also, be ahead of ChatGPT and other AI tools so that we don't miss the latest information and technology in the IT infrastructure. Okay, it was just a small suggestion, whatever I could explain from my side. Let's continue this expand from center function. Well, we will have a for loop. Okay, the for loop's necessity is, the while loop's necessity is that it will have left pointer and right pointer. Definitely we need a string also, but I think we can take the string from the top. Okay, so what we have to check is if left left pointer is greater than equal to 0 and right pointer is less than equal to less than s dot length, and we also need to check if the left and right pointers are equal. If they're not equal, we'll just return the current length, okay, of left and right because they match. So we are at, consider we are at A, okay. So A, we are at A, our left and right pointers are currently nothing. They are just 0, 1, that is 1, okay. So we also need to return right minus left okay. And we need to also check here if left string is equal to right string. If it is, then we'll increment left, we'll decrement left, and we will increment left, right. After this while loop, we can return our indexes, because if the condition doesn't match, we don't increment left and right, and at the same time we return the length of right and left. So in the first case where we are at 0, our right is A and left is nothing. So sorry, our right and left is same, this B, okay. Then our condition satisfies because left is greater than 0 and equal to 0. Right is also less than the length of the array, and s of left and right is equal. We are at B, so B is equal to B, okay. A single string can also be a palindromic string, okay. So after that we move forward, we'll decrement left and we increment right. So now left becomes -1 and right becomes +1. In that case, this while loop fails, and we come here and we have to now return the the length of the current index, which is just b and a. Am I right? No, it is just b, because for a and for this condition we failed because there is nothing on the left side. Okay, that's why the answer is just b. In that case, we return right, which is 0. No, because we incremented right and the first condition was true, which is b was same. Now we return. I will show you what we are going to do is we are going to take a sub string is equal to length is equal to, we will call our function expand from center, and we'll return right left as I comma I. Why are we returning I and I, and what is going to happen here? See, as I told you, if we are at a center, we'll check on the left and right if they're equal or not, and if they're not equal, we will return whatever is equal until now, and that will be the maximum length. If they're equal, we'll go till the end and we'll return the maximum longest string. And this is just not the case for this array, this string. It can be a longest string, and any middle part of it can be also an array. Like in this case, this is an array, but this is just for the odd length of the string. What will happen for the even length of the string? For even length of the string, we also need to check from the center if the left and right are equal or not. In that case, we can take two indexes in the center. Okay, we can take the left and right pointer to the very center of the string. In this case, we will take I and I plus 1. And how do we calculate I? So we just take the index, just write to it. Consider, because we are iterating I from left to right, we can just take two indexes. Okay, and that's how an even number number of length of a string will be calculated, is by taking two numbers, because these two numbers will only help us calculate if an string is palindrome or not. That's why we will be calling expand from center two times, one for the odd case and one for the even case, where in the even case we'll be having left and right pointer already defined as I and I plus 1. So considering this case, we have C, then we have B, B, D. In this case for C, we pass 2 pointers, so C and B will be passed. As we check right left, there is nothing on the left, so we return that itself. So CB was a palindrome. No, it was not a palindrome. C and B are not equal from any angle. Okay, they are not a mirror of each other. We increment the pointer to B, and we also pass second pointer after that, I plus 1. And now we check left and right, C and D are not equal, so we just return this B and B. Actually, we don't return B and B, we are returning the length of the indexes. Okay, so if you consider in this case, we have right left as 1, right as 2, but in this case we also are decrementing the left pointer and incrementing the right pointer, so it is difficult to return the perfect length. So check that left, why are we writing minus here? Because minus minus will become plus if left is going to on the left side, because it is going to be negative at some point. Okay, and Anyways, if it is not negative, it is at the left side, and right is at ahead, so right is always greater, and that's why we are going to subtract right from left. And always we need a -1 here because it's a zero base indexing. And if you see, if we are at B and our left is at here, okay, 0 1 2. Okay, now we subtract 2 from, because we were at index A here, okay, and this went to -1 for left pointer, so -1, and this is 0 1 2, so 2 minus -1. Okay, if we just ignore this -1, then 2 minus -1 becomes 2 plus 1, that is 3, which is not our length of our this palindrome. It is, this is not the length of our palindrome, because right is 0 1 2, and 2 minus -1, as if I'm not wrong, our left is, so I'm sorry, left is not -1. um, in this case left is 0 1, we are at this index, left is 1, and if you do minus minus on left, it will be 0. Okay, so left will be 0, right will be 2, so in that case our answer will be 2, but this length of the string is not 2, so we need to add +1 here. Okay, and we see that our even and odd will return the maximum of the length of our uh, palindromes. Okay, yeah, in this case we need a -1 because we consider right as 0 1 2, that is 2 here. Okay, 2 minus our left went to, if because your index is 1, if I assume index as 1, now we have decremented index to 0, and our left is 0, and we have now -1. If you don't add -1, our right is going to be 0 1 2, and our left is going to be 0, so 2 minus 1 is 1. Actually I'm taking a wrong case here, but incrementing -1 from this will definitely give the right length of the palindrome, because it's a zero base index. We can visualize it better if we debug it later. Okay, I will move forward because it's going to be a long video. So what we have to do now is we have to uh, we get the maximum. Okay, let's take the max length to be the max of math dot max of odd and even. Okay, we got the max length of our palindrome, but now we have to decide what is that index of the, what is that palindrome. We got the max length definitely at some point in our code. Okay, for here index we got 1, for this index we got 3, for this index we got 5, then we got 3, then we got 1. That's how we got our palindrome maximum length at every point in our code. Okay, but now we have to return the palindrome itself. Okay, so what we will do here is we'll define start and end indexes. Okay, so let start is equal to 0, let end is equal to 0, and then we are going to end is equal to 0. Now we are going to define and check if for every time we are going to check if a condition satisfied for start and end, that is if max length is greater than the start index minus end index. I'm sorry, the end index minus start index, because end index is definitely greater than the start index. And we are going to define our start indexes and end indexes. Okay, how do we define that is because we are going to uh, because we are at a particular index, consider this index, we are at this index, and we have to uh, calculate the max length. We have to calculate uh, our string, our substring, depending on this max length. So max length is 3. So what we do is our current index, okay, start index will be current index minus the end of the max length. Okay, so the current index minus current index is what, 0 1. Okay, and max length is 3. So we do max length divided by 2, max length minus 1, because the length minus 1 is the indexing, 0th indexing. That's why we do uh, max length by 2, max length minus 1. Okay, and end index will be starting from this index. Okay, we go till uh, starting from this index, we add this the max length. Okay, I plus max length and divided by 2, because max length is 3, so 3 by 2 is 1. So if you take any case, this condition is going to pass, but they are going to give values in decimal points. So we add a mat.floor which will give us values that satisfy our index values. Max, sorry, not max, floor. Okay, that will give us start and end index, and we need to return the substring as dot substring of the start index and end index plus 1, because substring takes one index and more and returns the string before the end index. Okay, that's why we need to add 1 here. I think everything is right. We can just run the code. If I'm not wrong, we are surely right. Yeah, and we can just submit it. Our code is right. We need to understand how this code is working. If someone doesn't understand it, just go through it, just go through other people's solution. If you don't get it, just go through why we are writing this, expand from center. And this is the function where we use the window sliding technique. Okay, so today we learned window sliding technique, and we surely will learn more algorithms and techniques to solve our problems and make efficient, make it faster. Okay, for now we are at fifth problem. We have finished our fifth problem, and we surely definitely go faster with our other problems, so that we will try to at least go up to 500 problems by the end of this year. Okay, I will just make a goal for 500 till the till this year, because 500 is a lot. Okay, we'll try to also start. We are going to start a new series where we are going to solve efficient problems again. The sub problems we have solved already, we are going to solve them again using an efficient approach. Okay, and whatever approaches people have mentioned in the solutions tab, we are also going to take a look at that and solve them again. So that's it for today's video, and we surely meet in the next video for the sixth question. Till then, bye bye, have a great day.